Okay. Hi, class. Yeah, I'm Dr. Z. Okay, I'll be your Math 212. Okay, instructor this semester. And then many of you guys are from my last semester, the Calc 1. Okay, but I really welcome the new of you guys. Okay, so to join the class. Okay, I will try my best to teach you guys. I promise. I always do that, okay? But you guys will have to really follow the instructions, the guidelines of the class and do your work, okay? Because calculus class, these are not easy classes, okay? So if you do not put enough effort on the class, nobody can guarantee that you can pass the class, okay? So in order to pass the class, we always have to work very hard, okay? Put enough effort on the class in order to pass the class, okay? Okay, so have you guys read through the syllabus or no? No, not yet. Okay, so I would like to spend maybe about 35 minutes, 40 minutes to like at least because it's the first class of the semester to go over the syllabus, okay, and the important information from the IB Learn, so you guys know what are the important part, okay, for the class. You need to know what to do for the class in order to pass, okay? So let's go over the syllabus at the first, okay? So at the first, okay, you can see that in the IB Learn, okay, in the class, okay, we have the announcements, okay, we have syllabus, assignments, modules, and everything, okay? We're gonna go through these, okay, navigations, okay? But first, let me know you guys at first. So I'm gonna take attendance for today at the first, okay? So sometime if I forget to take attendance, just let me know, okay? Well, the attendance does not count for credit. You can see later, okay? It doesn't count for credit. However, okay, I still need to like make sure that each time who are here in class, who are here in the physically in class or who are online somewhere, okay? So let me see. I think I can see us, okay? I can see that. Okay. Amanda? Can you talk, Amanda? But I know you're here, right? You're here, so I mark you for the class. So Mark?
I'm here.
Okay, Mark's here. And then we have a Galaxy 10. Who is this? Oh, Galaxy. Do we have a Galaxy? I don't think so. So Dini, can you talk? Yeah, okay, so you're here. Am I right? Did as my pronunciation correct, Dini?
It's just Dean.
Dean, sorry, because
That's
my
okay.
pronunciation is maybe wrong. Okay, please correct me. Okay, if I say something wrong. Okay, so Dean. Okay, I'll make sure that next time I call you correctly. Okay, so Dean is here. Welcome to class, you guys. And then let's see who else is here. Okay, Zach. Can you talk, Zach?
Hello.
Hi. Yeah. Welcome to class. Okay, so Zach is here. Dean's here. Mark is here. Okay, Amanda, I did it. Tyler, okay, Tyler's here, okay. And for you guys who are access to the class through the online, so Zoom, please make sure that you have a microphone next time so that you can talk, okay, so we can communicate in class, okay. And then in class, physically, we have William, right? We have John, right? Yeah, John. We have Nick. And also we have Brittany, right? Wow, the attendance is very good today. So we have a Dominic. So I wonder that is this Dominic? I don't know, okay? So I need
Me?
to, yeah.
Yes.
So you, Dominic, right? Are you there?
Yes.
Okay. Okay, good. So everybody's here. That's a very good start for the class, okay? So everybody's here, okay? I'm taking attendance every time, okay? So far, the attendance doesn't count for any credit because we'll see from the grading scale. However, okay, at the end of the class, I will see, okay? So if your grade is very close to a passing, and then you maintain a very good attendance record, so I'll think about to, give you some extra credit, okay? But, this is like I'm not sure yet, okay? So we'll see, okay? We'll see at the end, okay? Yeah. Previously from my Calc 1 class, if a student attend a very, have a good attendance record, I gave up to 2% of the bonus credit for attendance. But so far, I don't know yet. We'll see your progress, okay? However, I'll think about it, okay? So if you guys see that today's attendance is very good, okay? So I may think about it, okay? If your grade is very close to a passing, say you get a 69%, I'll check your grade for attendance. Oh, you attend class very often. Good, okay? Yeah, so we'll talk about that in a later time, okay? All right, so let's look at the syllabus and then go over the important information, okay? Okay. All right. This class is still under construction, okay, because we are using a new textbook. This is a Stewart textbook, early transcendental, okay. For me, even if I taught a Calc 2 many times before, but because of the new version of the textbook, I'm still adjusting notes and then, you know, do stuffs, okay. So this course is still under construction, okay. I will post the class notes and lecture videos gradually through the entire semester, okay? So check the modules frequently. We'll talk about the modules soon, okay? Under modules, you'll see important stuff, okay? All right, and then this is a course calendar for this class, okay? So let me open the file. Okay, I will follow the class calendar, okay, course calendar very tightly, okay? So except for emergency situation like the school is closing or anything else, most of the time I'll follow the, you know, course calendar to do lectures. Or if we make any changes, okay, about the schedule, I will let you guys know, okay? Say we have updated, you know, syllabus about we change, you know, sections, okay, I'll let you guys know, okay? So if we look at the course calendar, you will see that today we'll go over syllabus and also we'll do section 5.5, okay, substitution rule. On Wednesday, we'll do section 6.4 work, okay? So these two sections are kind of the independent two sections before chapter 7, okay? Next Monday, there's no class, okay? We don't have class, okay? So start from next Wednesday, we'll start to learn chapter 7, okay? So in chapter 7, we will learn how to do integrations with different skills, okay? Integration by parts, trig integrals, trig substitution, the partial fractions, and then, yeah, so entire chapter 7 is about how the techniques and the skills about how to do integration, okay? And then we'll also do chapter 8 for this class. It's about some application sections. There are only 2 sections we will cover: art learns and area of the surface of revolution, okay? And then chapter 9 is about, you know, do differential equations. So this is Calc 2, okay? After Calc 3, there's another class called a differential equation, okay? For you guys who are majoring in engineering, okay? I don't know everybody, nobody, I don't know, okay? Maybe you don't need to take the differential equation. You need to do that, right? Yeah. Okay, so differential equation is a class after the Calc 3, okay? So in that class, we'll talk about more in details about how to solve for differential equations. However, in Calc 2, we'll introduce some basic idea about differential equation and then, you know, learn some basic method to solve differential equations. So that's chapter 9, okay? And then we're also going to do chapter 11. This is a very heavy chapter and also very important chapter. It's about the sequences and the series, okay? So this is our schedule for the entire Calc 2 class, you can see, okay? And also you'll see that we are having 3 exams, okay? The first exam, okay, it is due on February 10th, okay? Because this class is a streaming video, okay, streaming video. That means, so for you guys who are accessing the class, you know, remotely, okay, you know, I will schedule you to take the exam in the testing center, okay? But for you guys who are attending class regularly, I'll also send you guys to take the test in the testing center, okay? So that means on the day of the exam, on the due date for the exam, there will be no class, okay? So as long as you finish your exam by the due date, you're good, okay? So there will be no class during the exam day, say February 10th, exam 1 is due on that day, but you don't have to be physically show up in class because you will take your exam in the testing center, okay? So when your test 1 is available, I'll send you guys an email saying, okay, your test 1 is available, so please make an appointment with the testing center and take the exam in the testing center, okay? So have you guys tried that before? You did? No, you're gonna give it a try, okay? So hopefully it will go smoothly. But if you encounter any issues or like problems, let me know, okay? Yeah, so all of the exam will be done in the testing center, okay? So exam 1 is due on February 10th. Okay, this is a most recent exam. Okay, and then you will see exam 2 is scheduled, well, is due on March 18th, which is in a week after the spring break. Okay, and plus all of the assignments will be due. Okay. All of these sections for exam 2 will be due on the same day. Okay, will be due on the same day with the test. Okay, exam 2, and then all of these assignments will be due on the same day with the first exam. Okay, so but on the exam day there will be no physically class. Okay. All right, and we also have a exam 3, which covers chapter 11. Due date is this, and the homework assignments are due as well. So homework assignments are all in web assign. We'll talk about it very soon, okay? And then 3 midterm exams plus 1 final exam, okay? Final exam is comprehensive. You're also going to do the exam in the testing center. So all of the exams are in the testing center, okay? All right. And then on the exam day, on the review days for the exam, see, we have a review for the final, we have a review for the exam, we have a review for the exam. For those review days, okay, those classes are optional. Optional means if you have questions, you come to class or you access to class remotely, you ask me questions, but there, I'm not going to lecture new stuff, okay? New stuff will be lectured during the class, regular scheduled class, the section time. But the review section is optional, means it's totally, I'm not taking attendance for that time, okay? So if you have question, you come. If you don't have question, you don't have to show up, okay? So that's a review. We'll talk about that, later about how to review for your exam, okay? How to prepare for your exam. I'll let you know today, okay? Today. Any questions from the course calendar? No question? Okay. Any questions, you guys?
No.
No? Well, you guys, if you have any questions, because you have a microphone, okay? So you can always talk, okay? So let me know if you have any questions, even during class, okay? Just because I can hear you, I can, get feedback to you, okay? So let me know if you have any questions. Let me know, okay? Stop me and then let me know. All right, so this is a course calendar, okay? This is our schedule. And then, where are we? Okay, let's go back to the syllabus, okay? Please let me make sure that we're recording, okay? Okay, so we're recording, good. Okay, so this is my contact information, okay? Send me email is the most effective way because I check my email periodically each day, okay? Or you can call me, okay? You can call me, but anything emergency, send me an email, okay? That's the most, quick way, okay? My office is in D140, okay? And these are my office hours, okay? For you guys who are local student and then you are attending class, on campus, okay? Stop by my office if you want, okay? To see me and then let me know if you have any questions, okay? During my office hours, and then this is my office, okay? And then my office is just next to the math lab. So you cannot miss my office. It's next to the math lab. If you know where's the math lab, you know where's my office, okay? All right, so this is my contact information. My supervisor's information is there. You can always, read through this information by yourself, okay? And this is a 4 credit hour class, and every Monday and Wednesday, we meet from 9:30 to 11:15, okay? So it's a 1 hour and 45 minutes in class, okay? It's a 4 credit hours course, okay? Okay, so these are the detailed information about what we will cover for this class. You can read through these by yourself. Yeah, course content, okay. And then the textbook is the Early Transcendental Essential Calculus Stewart book, okay, Stewart book, 8th edition, okay. So here, about the textbook, some of you guys ask me, do I have to buy a paper version or hard copy textbook? I would say no, okay. So for the class, because all of the homework assignments are in WebAssign, so what I need to know you have is to have a WebAssign access code, okay. So we'll talk about that later when we talk about the homework assignments, okay. Oh, homework assignments are here. So And then if you have an access code, website access code, you will be access to all of the homework assignments. And also there is an ebook inside. Okay, so you don't have to buy a paper version text. But once you bought it, fine. Because you're gonna take Calc 3, right? And differential equation, are you? Yeah, this textbook has Calc 1, Calc 2, Calc 3. So if you're taking Calc 3, you bought the book, no problem, okay? And then there is a access code as well, right? Okay, good. So if you can afford to buy a paper version textbook, go ahead to do so, okay? And if you buy a book brand new, I think there will be a website access code as well. So you don't have to buy the code separately. However, if it is too much, it is too expensive for some of you guys, you don't have to buy the book, just buy a code, okay? Just buy a code. Okay, and then for you guys who only need one to take one class, Calc 2 class, you don't have to buy the book, you only need to buy the code. So it's totally up to you guys, okay? And then let's talk about the homework assignments, okay? Oh, what did I press? Homework assignments are all in the web assign, okay? So then I need to move this somewhere. Ooh, how to move this somewhere? Because okay. All right, there we go. webassign.net. Okay, so for you guys to access the WebAssign homework assignments, okay, I think under the announcement, I post an announcement about how to sign into the class, okay? So just go to webassign.net, and then you will see that for you guys, if this is the first time for you to enroll in the class, just see enter class key, okay? Yeah, enter class key, okay? And then the class key, it is under the announcement. Okay, so WebAssign homework assignments, okay? Okay, so this is the website, and then please enter the class key. Oh, Ivy Tech. Okay. What is the key? 3963. Ooh, 3963. What is it? What is the one? Oh, okay, 3612. 3612. Okay, and then you will see the class, okay? And then click, yes, this is my class. And then after that, they may ask you to purchase a code. So that's a place where you can, yes, this is my class. And then they will ask you to sign up an account if you haven't get an account before, or you can sign in if you had an account before, okay? And then they may ask you to buy the code, okay? And there's one thing which is very important, guys. Some of you guys may not have the fund or money immediately to purchase the access code. However, I believe there is a free trial, right? Do you remember there's a free trial? Yeah, there's a 14 days, 11 days. I cannot remember. There's a free trial for the class. Okay, so if you don't have enough fund immediately, take advantage of the free trial. Okay, because you don't have to wait until you get the money, okay? So just use a free trial. I don't know where it is, but you can give it a try, okay? So I would suggest that enroll in my class immediately, okay, with a free trial, or use a permanent access code to access homework assignments, because we're doing the class quickly, okay? Today we'll do 5.5, and then Wednesday we'll do 6.4, okay? So after we're done each class, I want you guys to get the homework assignments done, okay? As soon as possible, because I don't want you guys to wait, even if the due dates are all on the same day of the test day, but you don't want to accumulate those knowledge, okay? So you don't want to wait until the last minute, especially for the higher level math classes. You don't want to do that, okay? So make sure that you have sign up to the webassign and get the homework assignments done, okay? Okay, so this is a homework assignments, okay? So now let me sign in. So I will show you there's an ebook inside as well. Hold on one second. Okay. especially for you guys who have not used the WebAssign before, okay? So you can see, oh, there are already still 3 students. Oh, I'm so glad to see this, okay? So the ebook is here. Once you click that, you will see the ebook. And then, so this is a, homework assignments for the exam 1, which will be due by February 10th. It covers section 5564 and then the 4 sections from chapter 7, okay? So once you click that, you will be able to see the homework assignments already, okay? So everything is set up, but the thing is, it's not completed yet. The whole semester is not completed yet. I will gradually upload more homework assignments. It's under construction, I told you guys, okay? All right, so where were we? We were at the homework assignments. Any questions so far? If I speak too fast sometimes, let me know, okay? Because I have this issue that gradually I speak fast. Do you feel I speak fast? A little bit, okay? So some of you guys, if you cannot follow me and then you feel like I'm speak too fast, do let me know. Oh, Dr. Z, can you please repeat this, or can you please speak slowly? Because, unconsciously, I will speak fast, okay? I need to slow down a little bit sometimes. Okay, so all of these makeup policies, okay, homework assignment, there's no quizzes, okay? There are no quizzes. So we'll only have homework assignments and exam. That's it, okay? So please read all of these policies. These are general policies, okay? I didn't write these, but I was given, okay? So just read these policies. Okay, grades, due dates and deadlines. For us, the due dates and deadlines are pretty straightforward. Exam day, homework due day as well, okay? All right. Last day to drop and withdraw, okay? If you want to get a 100% refund for the class, and then if you feel this class is not right, this is not your right class, and you don't want to stay in the class, or you don't like the class anyway, to get a 100% refund, please get it done by January 27th. So you have about 2 weeks to decide, okay? So this is some important day. The last day to withdraw is on April 11th, okay? So this is in April. So I will see your first 2 exams, okay? Yeah, because the third exam, which is after April 11th, right? This is too late. So according to your first 2 exams and also your homework assignments from the first 2 exams, for the first 2 exams, we'll see your grade. If your grade is way below 70%, I want you guys to talk to me. Okay, contact me and then we'll talk about it. Either you withdraw from the class, or if you stay in the class, what do you have to do? Okay, so that's an important day, April 11th. We'll talk about it later, okay? Instructor commitment, I reply to your emails. Oh, grading skills, okay? So homework assignment account for 20%. This is a, something, okay, 20%, okay? We have 3 midterm exams. Each will account for 20%, so 60%. And then final exam will be comprehensive. It is 20%, means final exam will cover the entire class material. It's going to be comprehensive. Okay, you know comprehensive mean, right? And then it's required for all Ivy Tech math courses. Oh, this is general rule, okay? Yeah, homework assignments, blah, blah, okay? So these are that. Tutoring, okay, we'll talk about tutor very soon, okay? For the exams, guys, okay, let me tell you how to prepare for the exam, okay? Because calculus classes are higher level classes here at Ivy Tech, and it is challenging, okay? They are challenging. So I created a list of the assignments for you guys to prepare for the final exam. Not for the final, for all of the exams, okay? So under the modules, okay, yeah, I'll talk about the notes, okay? You will see at least the 3 big parts, okay? So the class notes that I'm using in class, you can always download it and then prepare a copy in advance, okay? So it is here, okay? See, today we're gonna do section 5.5, okay? The class notes are here. I will use this notes to do the lecture, okay? So all of the class notes, okay, I will gradually post all of them, okay? And then after each class, because I record a class each time, so I will post the class videos in a later time. there may be a delay. So if you miss a class, you will have to wait for 1 or 2 days for the lecture video to be posted, because it is recording on the clouds, central office in down to Indianapolis somewhere. So it takes time to upload the video, their time. Okay, so when the video is completed, okay, uploaded, they will tell me and I will post the video. So either you come to class regularly, in class or remotely, or you have to wait a little bit for 1 or 2 days, I would say. Delay. The class lecture video will be delayed for 1 or 2 days. Okay. All right. And then there is a review list for all of the exams. Okay. We have 3 midterm exams and 1 final. I will create this review list for the exams. So for example, for the exam 1, how to prepare for exam 1. This is so important for you guys. Okay. From each section, okay, I pick up these questions from each section, say section 5.5, okay? So except for your homework assignments, okay, these are something you can do it on paper, do them on paper, but these are optional, okay? You don't have to turn in these, okay? So please use the correct textbook, the Stewart textbook, AC edition, early transcendental, okay? And then do these questions to prepare for the exam, because I will pick up questions from this list. I put these picked questions on your exam. So when you have your exams, okay, you take your exam, you will see if you do all of these questions from the review list, your exam questions will come directly from this list. Okay. Okay. Any question about how to review for the exams? Any question? No? Okay. So you know that if you do a review, okay, you do a good review, okay, you're doing these questions separately on paper, and then, everybody can pass the class, I believe, but you have to do your work, okay? See, exam questions come directly from these questions. I don't know, what are the questions, but if you do all of them, you will be very well prepared for the exam, okay? Yes. The final exam, probably you just need to use this list. Say, I'll have a review list for exam 1, review list for exam 2, and review list for exam 3. Final exam will be a list. You just go use the old list. Or if I come up with a new list, some actual questions, I also post it here, and also I'll let you guys know. Oh, please review for all of these questions, do all of these questions, then you are prepared for the final exam. Right? Okay, good. So this is a review list for the exam. Okay, so under modules, just check the modules periodically. You will see the class notes, lecture video, and review list for the exams. Okay, but homework assignments are online. Okay, those are mandatory. Okay, these are optional. However, they're important. Right, they're important. Okay, where are we? Let's go back to the syllabus. Okay. So grading skills, homework assignments. Oh, tutoring. Okay, tutoring. So because calculus class is a challenging class, okay, so you might need some extra help, okay? So I think on most of the Ivy Tech campuses, okay, they have a tutoring office. So in Valparaiso campus, at the Valparaiso campus, we have a tutor office. It is in D104. Oh, here. So D104, that's a tutoring office. Okay, so I believe every student can get per subject 2 hours per week. Okay, so check these places. Okay, you will get a free tutoring per week, 2 hours per subject. Why not? Okay, so this is one place you can go. Okay, and then if you're close to East Chicago, you can go this place. You could close to Gary, close Michigan City. I think they have the same thing. Okay, similar thing. Okay, for tutoring office. Okay, the other place you can do is you take advantage of the Math Lab. Math Lab is in D141 in Valpo, on this campus. Okay, so there will be instructors stay there, interns. Okay, to help students solve math problems. Math Lab. We also have a calculus tutor whose name is Dakota. Dakota was from our Calc 1 class. He will be staying in the Math Lab this semester as well. So you can check the schedule to see when I will be there, when Dakota will be there, and then there's some other instructor will be there as well. Everybody can can do this, okay? Yeah, can help you, okay? Everyone can help you, okay? The third method, which is the tutor.com. Have you tried this tutor.com before? You did? Some of you guys tried, some of you guys have not. If you haven't tried this tutor.com, you may want to give it a try, okay? So let me see whether the tutor.com is on our navigation or not. If not, I will have to put it on our navigation. Where's tutor.com? It should be, oh, okay, it's not there yet, but I'll make sure that after class, I'll make sure the tutor.com is available for us, okay? So take advantage of it, okay? The tutor office, the math lab, the tutor.com, of course, the most important resources is me, okay? So if you have any questions, concerns, see me in my office during my office hours, or send me an email, or talk to me in person if you come to class in person, okay? Let me know any of your any questions, concerns, anything, okay? I will try my best to help you, okay, to help you. All right, so where are we? Okay, here, we're almost done for the syllabus, okay. All right, so attendance and participation, yeah, this is, I don't know whether this is works for our class or not. This may work just for traditional class, okay? Please read it, but for our class, synchronous, either you come to class or you do it remotely, or if you don't have time, watch the video in a later time. So all works, okay, all works. And then these are our, yeah, scheduled assignments. Homeworks for 3 exams, and then due dates for the 3 exams, you know. Final exam, you know, what is the due date. They're all in the course calendar, okay? And I will do the attendance every time, okay? All right. So any questions about the syllabus? Questions? Okay. Okay. All right. So if no questions, I'll go over these navigations, important navigations very quickly for us, okay? Okay. You guys did a great job, amazing job. So I don't think I need to repeat this, okay? Because you guys are here, that means you already read through this, okay? Web assigned homework, we did it already. We looked at it already. Class notes and the videos, they're all under modules, okay? So I put the class notes and the class videos under modules, and even the review list for the exams, okay? So check the modules, okay? Formula sheet in the exam. This is something that I would like to talk about a little bit, okay? So you're allowed to prepare a formula sheet by yourself, okay? Because different students feel different way. Oh, you feel this formula is hard to remember. Different student feel another formula is, you know, hard to remember. So I will allow you to prepare a formula sheet by yourself, okay, when you take the exam. Okay, so it will be on one side of the paper. Okay, you're gonna accommodate all of those formulas that you feel, oh, these are hard to remember. I might need this on your in my exam. Put those formulas on your formula sheet. Prepare of one side of the paper formula sheets. Okay, then you are going to bring this formula sheet to the testing center, because I would you know, I will let the staff know that you are allowed to take a formula sheet. Okay, to use a formula sheet. So your testing center staff will collect it, okay, when you're done for the exam, and return your exam plus your formula sheet back to me, okay? If your staff forget to ask for your formula sheet, to collect your formula sheet, please remind the staff and turn in your formula sheet, okay? Because when I grade your exam, I need to make sure whether you have a formula sheet, or if you don't have a formula sheet, you don't want to use a formula sheet, just tell the staff, please let my instructor know that I don't have a formula sheet. Okay, so I know you don't have a formula sheet. If you have a formula sheet, I need to check what's on the formula sheet. On the formula sheet, I do not expect to see any specific questions. No specific question, just the formulas. Do you know the difference between formula and then a specific question? Okay, so there will be no specific questions on the formula sheet. There will be only formulas. Say, for example, we're going to do, say, for example, we're going to do section 5.5 today. Okay, the substitution rule. On your formula sheet, you can put this on your formula sheet. That's fine, okay? This is a formula, okay, formula. Or you can put this on your formula sheet. fine, no problem. However, I do not expect to see a question on your formula sheet with detailed solutions. I don't want to see that, okay? And then for you guys who took my class before, Calc 1, you know what to put on your formula sheet. But for you guys who are new to this, the class, okay? Okay, so you know that on the formula sheet, only formulas will show, okay? Otherwise, okay, no, okay? So that's why I need to really check your formula sheet. Without formula sheet, I will not grade your exam, okay? What's up? 8 by 10. That's 8 by 11, right? That's a A4. It's an A4 size of the paper. Yeah. You don't, if you want to make it small, fine. But you can use a regular A4 size of the piece of paper. Okay, A4 size. Or your script paper, the notebook script paper, just use, but one side. Okay, one side. Okay. So I need to check your formula sheet. Okay. And then I will grade your exam because I will collect your exam online from the testing center. So make sure that this is available to me. Okay. All right. Any question about the formula sheet, you guys? No? Okay. No questions. Okay. So let's go back to where? Oh, okay. Announcement. Exam proctoring. Okay. So this is also something new for us. Okay. Because I think you guys took Calc 1, you know, in class, but Calc 2 is streaming video. Okay. So there are two options for you to take the exam. Okay. One option is to go to an Ivy Tech testing center, okay? So make an appointment for your exam, okay? So far, I haven't done for the proctor form yet, okay, but once I'm done for the proctor form for the exam, for the exams, I'll send you guys an email saying, oh, our exam 1 is ready for you to take at the testing center. So you guys can go ahead to make an appointment, okay? But don't do it right now. Don't make an appointment with the testing center right now because your exam is not there yet, not. Okay, wait for me to send you guys an email saying, oh, that your exam is available. Please make an appointment. Then you go ahead to do so. Okay, so you do this at a testing center for free. This is one option. The second option is some of you guys, you don't have a chance to go to a testing center. Okay, or if you do the class, even outside the states, I even have students take my class outside of the Indiana. They're in Michigan. They're in like Illinois. Okay, so you can also take the exam through ProctorU. Okay, however, if you're using ProctorU, you have to pay for it. Okay, they will charge you a fee for about $19, $20. I cannot remember. Okay, so per exam, you will have to be charged for that. And whoever want to you're so tired, you guys are so tired. Okay, so whoever want to use a ProctorU, please let me know, because so far I would assume everybody will go to the Ivy Tech testing center. Okay, if you want to use ProctorU to do your exam online, let me know. I will have to go ahead to schedule your exam manually. So if nobody contact me through ProctorU, I will assume everybody go to testing center. Okay, but whoever want to use ProctorU, let me know. Otherwise, you will not be able to schedule your exam through ProctorU because I will not schedule it at a ProctorU, okay, if you're not telling me, okay? So you do have two options, okay? One free and one you have to pay a little bit amount of money, okay? So these are the two options for the exam, okay? And then the classroom of the class, okay? Even if the class is a streaming video class, okay, I do this through the Zoom, okay? But I still have a physical classroom on campus in Valparaiso campus, which is in D110, okay? So today I have 4 students physically show up in the class, okay? That is because I told you guys too late, okay? It was just 30 minutes before the class. It was kind of too late. Okay, for you guys who are doing the class remotely today, and if you want to attend the class physically in person, you're very welcome to come to class as well, okay? So you know where is the classroom? It's in D110, okay? So either in D110 or you do it remotely, okay? So it's up to you, okay? But just want to let you know that you have an option for the class, which is on campus in D110, okay? All right, so these are all of the announcements. Any questions? Questions? Okay, so attendance, IV advising. Yeah, I believe that's everything that I would like to cover. Okay, so syllabus, we read that. Assignments, you will see the grading skills, 20% homework assignment. Each exam, midterm exam account for 20%, final exam 20%. And under modules, we saw that already grades, you'll see these are the people. Under files, I don't think we have many stuff there. You can check that as well. But if you check modules, that should be enough, okay? And I take attendance every time. Okay, so purchase course materials. I told you guys just do it from the IV WebAssign, and then either you buy a code or you buy a physical book with a code, either way, okay? All right, so this is everything I would like to say. Not everything, okay? I forget about one thing, okay? This class, we meet 4 hours a week, right? 4 credit hour, we meet 4 hours a week. So in order to pass the class with a decent grade, I need you guys to spend some time extra, okay? After class, you have to spend time. Otherwise, just the class time is not enough. I need you guys to spend at least the double of the class time extra each week to do your homework assignments, to review or preview the class notes, and then to, you know, do the review list questions, okay? So do the math. How many hours do you need extra? Except, okay, 8 hours, okay? Yeah, you computed very quick, you know, correctly. I need you guys to spend at least 8 hours per week to study the Calc 2 class, okay? So do your homework assignments, read your textbook, you know, do your review list questions, and then, you know, go over the class notes, and then do anything related to Calc 2 for about 8 weeks. Trust me, guys, everybody can pass if you follow the direction, instruction, okay? Because a lot of times students complain about the math is so hard is because they did not put enough effort. That's the issue, okay? Trust me, okay? As long as you put enough effort, you study, you ask questions, you attend class, you do everything that I expect you guys to do, everybody can pass. Everybody is smart. Everyone is smart enough to pass this class, trust me, okay? So do put some effort on it, okay? All right, so this is what I want you guys to know before, you know, we are actually going to do the class notes, okay? Any questions about the syllabus? Any question? It is pretty straightforward, right? You know what to do, right? The exams, how to prepare exams, you know, how to assign to WebAssign and do the homework assignments, right? And then that's it, okay? Okay. All right, so that's a syllabus, okay? And then now we are going to look at the section 5.5, okay? So after today's class, we're supposed to finish up learning section 5.5, okay? Can you guys see the screen, everyone? I just want to test out. You guys can see the screen, right? Okay, all right. So section 5.5, the substitution rule, okay? Well, this is the only section that we do from chapter 5. Okay, and then chapter 5, do you still remember what we learned from chapter 5? If you have your book with you or you have an ebook with you, do you remember we had learned from chapter 5? Okay, so if you don't remember that, that's no problem. Okay, I just want to briefly talk about the first 4 sections from chapter 5 because for the Calc 1 class, we had already covered those sections. So I'm not going to repeat those sections. However, the entire chapter 5 is about integrals. Remember that, okay? Remember we talked about in Calc 1, okay, that for the calculus, okay, for the calculus, there are 2 main categories. What are the, I cannot say categories, like main branches. What are the 2 main branches for calculus? Difference, right? Differentiation, right? This is one branch. What is the second branch for the calculus? Integration, okay? Remember that? In Calc 1, we mostly talked about what? Differentiation, right? How to do derivatives, right? Remember, first order derivative, second order derivative, right? We did the derivatives. And then in Calc 2, we'll concentrate on what? integration, okay, integration. And plus, we'll also do what? Something else, like sequences, series, differential equation, and something else. But you know, for calculus, there are two big branches, derivatives and then integrals, okay? So we start from the integrals. You know, for Calc 2, we start from the integrals. So chapter 5 is about integrals, okay? All right, so the first 4 sections, we talked about how to find a Riemann sum. Remember, we cut those irregular shapes into different triangles. We use rectangles to approximate those areas, right? We compute the areas for the rectangles. Remember, left endpoint, right endpoint, endpoint, blah, midpoint, something, okay? So area distance questions, we did area problem. We learned about definite integral. We also learned the indefinite integral. Do you still remember what's the difference between definite integral and indefinite integral? Do you still remember? Definite integral is what? Are these integrals definite or indefinite? Is this integral definite or indefinite? Definite, okay? If an integral involving what? Limits, lower limits, upper limits, it is called a definite integral, okay? And then the integrals with no limits, they're called what? Indefinite integral, okay? So we learned these before, okay? So please go over the first 4 sections by yourself after class, okay? If you forget about how to do integrals, please review them, okay? And then the fundamental theorem of calculus, we learned about this. We're not repeating them. If you forget, oh, what are these fundamental theorems? Check them, okay? This talks about the relationship between differentiation and integration are as inverse processes. Remember, we learned that as well. And section 5.4, we learn about how to do indefinite integrals with what? Formulas, okay? With formulas, okay? So if you forget about how to do the integrals, I would prefer that. Where is this section? Indefinite integral, where's the table? Yeah. So this is definite integral. Okay, there is a table I'll show you very soon on the back of the textbook. It's about tables for integrals. You will have to review for that. Okay, where's the book? So before we learn section 5.5, okay, I need you guys to really have enough background for the integrals, okay? 11. So there is a table somewhere. Hold on one second, I will show you. If you have your book with you, there is a reference pages on the back. In the back of the textbook, tells us the tables. Okay, there we are. Okay, so this is the reference page number 6. Start from number 6. You will see page 7, page 8, page 9, page 10. Okay, so these are the tables of the integrals. Okay, so we haven't learned this yet. Okay, this is integration by parts. Okay, but in the table you will see the basic formulas for the integrals. Okay, like a powers function, right? Oh, there we are. Okay, so I want you guys to really have a review about how to do the integrations. Okay, the basic formulas you have to know. These are for the trig functions. Okay, for trig functions, and also some of these. Okay, you have the table. Okay, I have these. Okay, and reversely. Okay, derivative is a reverse action for integral. Okay, so if the integral of sin of function is negative cosine, we know cosine function's derivative equals what? Negative sin, right? We know that. Okay, so I want you to review for both of the derivatives and the integrals, and then those basic stuff, okay, before, okay, the section 5.5. But if you don't have time in class to review, I would strongly suggest you review those old knowledge that we learned before after class, okay? So now we have enough background, okay? And then in chapter 5, we'll only do section 5.5, okay? This is a technique section for us to do what? Some integrals with a little bit of complicated functions, okay? How to do some complicated functions and then how to do integrals. If we do not have a formula to use directly, how are we gonna do the integration? Okay, so this is a section 5.5, substitution rule, okay? All right, so see, this is the notes I'm using, okay, for this section, okay? So, all right. We have the rule directly here, okay? I'm going to ask a volunteer to read this rule for us. Anyone in class want to read the rule for us? John?
If u is equivalent to g of x is a differential function whose range is an integral and is that
I.
function is continuous on I, then the function before is true.
Can you read? Integral of?
The integral of function of g of the function of g of x.
F of g of x, right?
F of g of x, g prime x.
Yeah, dx.
d of x is equal to the equivalent function of u dθ.
Okay, very good. Thank you so much. Okay, so this is a formula sheet for the substitution rule of the indefinite integral. Okay, well, when we encounter an integral, say for example, this question A. Okay, so for example, question A. We want to do an integration. Okay, question for you. Do we have a direct formula we can use, like a power rule something or some direct rule we can use to do the integration for this function? It is really hard to use a direct formula, right? There's no direct formula. However, we see that, okay, there must be, some complicated parts of the function. See the function. See, for example, let's use this as an example. The integrand is what? The integrand is x times by parentheses 4 plus x squared to the 10th power, right? To the 10th power. So x, it is a power function. It is a simple function. However, x times by the parentheses 4 plus x squared to the 10th power. This is 4 plus x squared to the 10th power. See, just for this part, I'm asking you guys, is this part of the function a composite function? Do you understand a composite function? F of g of x. See, it has an outer function, it has an inner function. So f of g of x is called a composite function, right? It is called a composite function. We learned this before, okay? But if you forget about it, fine, okay? It's called a composite function. And for the composite function, there is an inner one. What is inner function? G of x, right? Because g is closer to x, okay? So g is called a inner function. How about f? F is outer function. We call it outer function, okay? Outer function. So when we have composite functions, f of g of x, it is hard for us to do the integration of f of g of x times by g prime of x. Okay, so what do? We're going to let what? We're going to let u equals the inner function g of x. Okay, so if we let u equals g of x, this function f becomes f of u only, right? So it's simpler. There's no two layers. See, f of g of x, there are two layers. But if we let this entire g of x to be u, we'll only have f of u, which is just one layer of the function, right? Okay, so see this integrand, if we let g of x to be u, it becomes what? F of what? U. Then, because now we're using the new variable u, okay, the integral has to be in terms of u, not in terms of x anymore. So if u equals g of x, we differentiate from both sides, okay? Left-hand side, we'll have a d of u. U is a function of x, okay? Right side, we differentiate with respect to x, give us what? g prime of x what? dx. Okay, yeah, differentiate both sides from this u equals g of x. It gives us a du equals g prime of x dx. Okay, now guys, let's see. For this complicated function, if we use u equals g of x, it becomes f of u, right? Right, guys, here. And then what is this? What is a g prime of x dx? It equals what? du. See, this complicated integral becomes f of u du, only one layer of the function. So it will be easier for us to find the antiderivative of what? F. Okay. However, here, I just want to say, once we get an antiderivative of f, it will be still an antiderivative in terms of u. Don't forget to change the u back as what? G of x. Because the integral, it is for x. Eventually, the antiderivative must be what? In terms of x. Okay, so I'm going to show you this idea by using this question. Okay, so we have x times by 4 plus x squared to the 10th power. Now, just now we talk about this function. 4 plus, yeah, this part, okay. 4 plus x squared to the 10th power. Can we consider this part is a composite function? Can we? Which, can you tell the functions? What is the g, what is f? 4 plus x squared, if we let 4 plus x squared to be our g, right? And then this something to the 10th power becomes what? What is f? What is f now? F of u is what? U to the 10th power, right? Guys, do you see that? Well, I'm just writing this, but you don't have to write this next time, okay? Just make sure, if we let u equals 4 plus x squared, this is the inner function, okay? Then the entire composite function becomes what? Because 4 plus x squared equals u. So this entire part becomes u to the 10th power, right? Okay, so u to the 10th power, okay. All right, so the thing is, once we have we let u equals 4 plus x squared, okay, I'm gonna get rid of this because, you know, it makes you guys feel so confused sometimes, okay. Well, you can keep the equals g of x, is correct, okay. So if we let u equals 4 plus x squared, let's compute the derivative. Du will equals what? Differentiate both sides. The left-hand side with respect to u, we have du. Right side with respect to x, we should have what? Derivative of 4 with respect to x, 0, because 4 is constant. Plus, x squared's derivative is what? 2x. Ooh, this is g prime of x. But don't forget to multiply by what? dx. Okay, so once we substitute 4 plus x squared by u, make sure we do the derivative, du equals 2x dx, okay? Okay, this is a key, okay, for substitution rule, okay? Now, guys, let's rewrite this integral, okay, and see what we can get. It will becomes what? 4 plus x squared to the 10th power becomes what? U to the 10th power. Do you see that? Yeah, this part is u to the 10th power. However, we're still having what? X times by what? dx. We're still having x times dx. We have to make sure that to rewrite this in terms of du. So x times dx. Can we rewrite this x times dx in terms of du? If du equals 2 times x times dx, I say x times dx equals half of du. If we divide by 2 from both sides of the equation, that gives us x times dx equals du over 2. Do you agree with me? So here we can replace x times dx by what? 1/2 du. You guys, Oh, see, this is a, integral only in terms of u. Are you able to get the antiderivative? This is a power function. So what is antiderivative? Anyone tell me? Please tell me. You guys? Yeah. U to the ninth. Okay, let me write it here. X to the alpha's power dx integral. Alpha is a constant here. So how to find its antiderivative? This is not a derivative. If we're having a derivative, x to the alpha's powers derivative, it gives us alpha times x to the alpha minus 1. Remember that for derivative? But for antiderivative, what should we do? We're adding the alpha by 1, right? And then times by x to the what? Alpha plus 1. And then because this is a indefinite integral, we have to plus a constant c. So if you forget about this formula, fine, but make sure you review, okay? X to the alpha dx equals 1 over alpha plus 1 times x to the alpha plus 1's power plus constant c. Now, u to the 10th power, what should we do? 1/2 is still 1/2, right? So alpha is 10 now. We should have a what? 1 over what? 9 or 11? 11, okay. And then times u to the what? 9 or 11? 11 plus the what? Constant c. No integral sign. We always have to plus a c if it's an indefinite integral. So let's simplify the coefficient. 1/2 times 1/11 give us what? 1 over 22. U to the what? 11 plus c. Can we say we're done? No, remember just now we said this original integral is in terms of what? X. But we're having u here. Don't forget to substitute a u by 4 plus x squared back. So eventually the answer is going to be 1 over 22 times what? 4 plus x squared to the 11th power plus a constant c. Done. Now done. Any question about this question? See, what do we do, guys? How do we use a substitution rule? When we encounter a simpler function times by a complicated function, what we should do what? To use substitution rule to make the complicated function more what? Simpler. So what do we do is make sure, oh, we're having composite function. The inner one is 4 plus x squared. Because if we let u equals 4 plus x squared, this entire function become u to the 10th. Oh, it's a power function. It's easier. It become easier. So we let u equals 4 plus x squared. And then don't forget to every time we have to compute du, okay? And then we can rewrite the original function from x by u and then become a simpler function integral. We get the antiderivative and substitute the u back in terms of x. This is the idea for the substitution. What do you feel? It's all right, right? It's all right. Okay. All right, now, no question, right? Any questions from you guys? Remotely? Dean, question about this problem? Question A?
No.
No? Amanda? Amanda? Okay. All right, so you guys are watching, okay? No problem. All right. Now let's look at question B. I may ask you about what to do for the question B. Integrate x times by sin of x squared dx. Think about it. X is simpler, right? We have a sin of x squared. Any suggestion? Anyone from the class and remotely? You guys tell me. Sin of x squared. This part gives us a composite function, right? So sin function, sin of something. composite function. Outer layer is sine function. Inner function is what? X squared, right? That's our G, right? G equals X squared. How about we let what? Yeah, because we don't know what is sin of X squared and the derivative. We don't know. But we know sin of U. So what do we do from here? Once we get a substitution, we always have to compute what? Please tell me, you guys. What? Amanda? I heard you. Once we get a U, we do what? We do du equals what? Differentiate x squared give us what? 2x times dx. Oh, you guys, I need to say something, okay? You guys who are attending remotely, okay? So if you're not talking, you guys, if you're not talking, please mute your microphone, okay? Because if you're not mute your microphone, and then everybody may hear your background noise, okay? So if you talk, make sure that you you have your microphone on, okay? But if you're not talk, okay, make sure you at least you stay in a quiet place where you mute your microphone, okay? All right, thank you. Okay, so what do we do now? How about you guys tell me? I need some feedback. Integral becomes what? 1/2 integral of what? Sine of what? U du. Ooh, how did you get that? William? Yes. Yep. Yeah. X dx gave us 1/2 du, and then x squared becomes u, that gives us sin of u. Very good, thank you. And then antiderivative for sin u is easy, right? What is it? Cosine or negative cosine? Negative cosine, because cosine u's derivative equals negative sin. So since use antiderivative equals negative cosine, okay? So negative 1/2 cosine of u plus what? Constant c, because it's indefinite integral. Are we done? No, replace u back as what? X squared. So eventually answer is what? Negative 1/2 times cosine what? X squared plus constant c. All right. Okay, now question C and D. I want you guys to think about these two problems for a couple minutes, okay, for 1 or 2 minutes. And then we'll talk about what is a U. Then what do you want to, the U to be what? Then I'll let you guys to do these two problems in group, okay? So let's look at C. 1 minus 2x parentheses to the ninth power dx. If we use substitution rule, which part do you want to be set it to be U? Yeah, okay. So let U equals 1 minus 2x. You're gonna try this, okay, in group, okay? All right, question D. We're having ln x squared divided by x dx. What, ln x? Okay, good. Yeah, see, ln x squared, this is a composite function, right? So let U equals ln x. Okay, so now I'll give you, 5 minutes, okay, 5 to 8 minutes to try these two problems. William, Bill, can you please come over here to, to join the group? You guys, group work, okay? You 4 will try to finish, to do these two problems together, okay? And then for you guys who are doing the, class remotely, guys, please have these questions, try to do these questions by yourself, okay? Eventually, I'll show you the answer, okay? But now it's a group work time, okay? I would like to see, can you guys see me? I mean, some of you guys sit here and then write your answers and then show everybody, okay, in the class. Okay? Yeah, remotely for those people who are doing the classroom group. I think so. Let me check. CNB. This is okay, so Brittany. Sorry, you're ready. Okay. So we're also going to talk through the microphone. I am. All right. It's more. Maybe not talk to you, but you're gonna.
I'm gonna talk to them. Okay. Hello, everybody. Do you want me to use red or black? Doesn't matter. Okay, so I'm gonna do C, I guess. So she already told you what your U is, and then your du will equal -2 dx. So the integral of u to the 9th times du over -2, because you divide it out over there. And then you have your -1/2, the integral of u to the 9th times du, which equals 1/10 u to the 10th plus c. So then you fix that and you have 1/20 and you plug in your u. And there you have it. Okay.
All right, hey everybody. So if u is ln of x, then du becomes 1/x dx. Your 1/x and dx are right here. You take them out for du, and then plug your u. Becomes u squared du. Let's simplify through. 1/3 u cubed plus c. Plug back in. Oops, sorry. A little bit of a messy writer. But that's all right. X3 over 3 plus c. A pretty quick plug and chug on that.
Thank you. Good job. Good job, you guys. Hello, class. Hello, class. Dean, you can hear me? Amanda? Okay. All right. So for these two questions, okay, I think, we had Brittany and Bill came to, did the two problems, okay, and then both of them did them correctly, okay. Yeah, they do them correctly, okay. So once we have the u, compute the du, substitute the original integral as in terms of u, find the antiderivative, and then don't forget to plug in u back as 1 minus 2x for this question, okay. So answer is this for question C. Okay, for question D, let u equals ln x, du equals 1/x dx. So the original integral become u square. And then dx over x is what? Du. So antiderivative is 1/3 u to the cube plus c, and then plug u back as ln x. That gives us the ln x to the cube over 3 plus c. Perfect. What do you feel so far? So far so good for the substitution rule? Okay. All right. So these are questions about compute integrals by using substitution rules, but these integrals are indefinite integral. We only need to do a substitution. We don't have to worry about the limits. And then this is how we do them, okay? However, okay, if we're, there's one more question E, okay, this question E, okay, I don't think we have time because we only have 20 minutes, okay? So I will do this question very quickly for us, okay? So you guys can check, okay? Or you can try in a later time and then check. 1/5 minus 3x, what do you want to be our u? Yeah, 5 minus 3x, okay? So we did the whole thing, okay? Some of you guys say, how about I let the 3x to be u? You're gonna see, if you let 3x is u, we'll still have 1/5 minus u. It does not make the computation easier. The reason why we want to use substitution rule is we want to make the computation, calculation easier. So that the entire denominator to be u, then du will be what? -3 what? dx. Okay, yeah, 5 derivative is 0. -3x derivative is -3 times dx. Okay, so we know dx should equals what? Or I would say here, this is equivalent to what? dx equals negative what? Yeah, -1/3 times u, right? Okay, so the original function becomes 1/u. What is dx? -1/3 du. You guys? All right, what is antiderivative for 1/u? We know it is what? Ln absolute value of u, right? Plus the constant c. And don't forget to plug in u as 5 minus 3x back here. So answer will be -1/3 ln absolute value 5 minus 3x, because this is original substitution, okay, our substitution, okay, and then absolute value plus constant c. You guys, so that's good for this question? Okay. All right, now we're talking about use substitution rule for definite integral. It is harder, okay? It is harder than the indefinite integral, okay? So you will see why, okay? I'm gonna ask a volunteer to read this rule for us, okay? I'm gonna find somebody from the class, okay, remotely, and read it, and I'll see who's here. Dean, can you unmute and then read the rule for us, please?
Yeah.
Yeah.
If G prime is continuous on AB and F is continuous on the range of U equals GX, then the integral from A to B of F of G of X, G prime of X dx equals the function G of A to G of B to function of U du.
Okay, very good. Thank you so much. You guys will not hear it. Okay, I can hear it, but you can see my finger. Okay, where I'm pointing, that means he's reading that part. Okay, okay, very good. So for definite integral, okay, we're having what? We're having the limits. Okay, we're having the limits. Okay, so if we're using the substitution rule, okay, we let u equals what? G of x. Okay, similarly, okay, we let u equals g of x. So f of g of x become f of u. You guys get that, right? And then same thing. du equals g prime of x dx. This means g prime of x dx becomes what? du, right? No problem. However, guys, for the limits, Previously, these two limits a and b are for x. Now this integral become u in terms of u. So the new limits has to be changed. Okay, how to set up the new limits? This a is when x equals x, right? So if we become a integral in terms of u, so when x equals x, u becomes what? When x equals a, u becomes what? G of a. When x equals b, u becomes what? G of b. So that's why when we have a new integral, I would say one new integral because there's no x anymore. This integral only in terms of u. Make sure we have to change the limits for u. Okay, we're not using the original limits, we're using the new limits. How to figure out the new limits? What do? When x equals a, compute u by using the substitution. Okay, when x equals b, compute g of b for our upper limits for the u. This is the only difference between the definite integral and the indefinite integral. For indefinite integral, you just use substitution and plus c eventually. But for definite integral, because we have the limits, eventually we have to change what? The limits for the definite integral. You guys, that's good? All right. And then for definite integral, once we change the limits for the u, eventually we'll have a fixed number for, we'll have a fixed number as a result. Do we have to change u back to in terms of x or anything? No more. Okay, you guys, so that's good. Definite integral, eventually the answer should be what? A fixed constant. It's a number. So once we get that number, we're done. Okay, we don't have to change u back in terms of x because definite integral is a family. The result is a family of functions. Okay, it's not just one function, it's a family. C could be any real numbers. Okay, however, for definite integral, the result is a constant. So once we get the constant from the newer integral, we're done. Okay, because we have already changed the limits for u. Okay. All right, so now guys, let's look at both of these two questions. We're gonna do both of them, okay, in 10-15 minutes, okay. Now, evaluate this integral from 1 to 2, e to the 1 over x squared over x squared dx. Any idea? E to the 1 over x. Right, we don't like that 1 over x, right? We know e to the x, or e to the u, right? So how about we let u equals what? 1 over x. What do you think? Because we know e to the u antiderivative, but we don't know e to the 1 over x. What is the antiderivative? So if we let u equals 1 over x, compute a du becomes what? Okay, if you don't remember that, okay, you can use the power rule, okay? When u equals x to the negative 1's power, the derivative of u should be what? Negative 1 times x to the what? Negative 1 minus 1, right? Remember? So negative 1 times x to the negative 2, which gives us negative 1 over x squared. Okay? You guys? All right, so let's see what we will have for our newer integral. Okay, I'm not talking about the limits yet. We're just talking about this part. E to the 1 over x becomes what? E to the what? U. And then we also have a dx over x squared. Dx over x squared can be rewrite as what? Negative what? Du, right? Negative du. All right, now here is the thing. The limits for u. How to figure out the newer limits. Or I can just, include this. Because u equals 1 over x. So when x equals 1, what is the u value? 1. 1 over 1 is what? 1. Okay, so The lower limit for u is 1. When x equals 2, u equals what? 1/2. Ooh. So if you understand this step, that means you really understand the definite integral, okay, using the substitution rule, okay? This is a key, okay, because we have to change the limits for definite integral. And then from where? Substitution. That's the substitution. Give us the relationship between the original variable x and the newer variable what? U. Question about the 1 and 1/2 as limits? No? Okay. Now let's do it. This is easier, okay? So e to the u's power, what is the antiderivative? E to the u, right? And then we have a negative in front. So this is negative e to the u. And remember the substitution rule or the evaluation theorem? This is antiderivative capital F, right? We have to evaluate the capital F from what? 1 to 1/2, right? So capital F evaluated at 1/2, when u equals 1/2, give us negative what? E to the what? 1/2, right? And then minus negative e to the what? 1, right? And then minus become positive. So this is e, right? This is actually e. And then minus e to the what? 1/2. Done. And then you may say, what is this? Because e is a natural number, right? So e to the first power is also a natural number. It's a number. E to the 1/2 is also a number. A number minus number is a number. So see, the result for a definite integral is indeed a number. We don't have to worry about to change u back in terms of x. We don't have to. Okay. Was good for this question A, everybody? Can you give it a try for question B? I will give you a couple minutes to think about it and then give it a try. I'll give you 3-4 minutes to do it. And then after 3-4 minutes, I will show you the key directly, okay? Because we're almost, time is almost up. Now just think about to let what equals u. So what substitution did you try? Yeah, let u equals what? Natural logarithm of x, right? ln x. Then we should have du equals what? 1 over x dx, right? And then the original integral becomes, see, I always make sure that I calculated the limits later, okay? Or you can do it at the first. So we have dx over x is what? Du. Okay, see here. dx over x is du. Okay, and then we have a 1 over square root of u, right? So we should have a 1 over square root of u du, right? 1 over square root of u. And dx over x is du. And then to compute the limits, use a substitution. When x equals e, u should equals what? ln e. What is ln e? What is ln? Log to base e. E. 1. When x equals e to the 4th power, ln e to the 4, okay, so this is log base e to the 4th power. Remember that property, a natural exponential, natural logarithm as a what? Inverse function, offset, right? So we have a 4 left, right? Okay, so 1 to 4, 1 over square root of u du. What is the net antiderivative for 1 over square root of u? We did this several times in our calc class, okay? I'm gonna do it one more time and I want you guys to remember the results, okay? I say 1 over square root of u du equals 2 times square root of u plus the constant c for definite integral, okay? How do we get this result? This is 1 over u to the 1/2 du because square root of u equals u to the 1/2, right? And then this gave us, because this is 1 over, it is actually u to the negative 1/2 du, right? And then u to the alpha's power du by that power function, right? We should have a 1 over, this is alpha, right? Alpha plus 1 times u to the alpha plus 1 plus the constant c. Okay, what is this? Yeah, what is this is negative 1/2 plus 1, which is 1/2. 1 over 1/2 is what? 2. U to the negative 1/2 plus 1. Negative 1/2 plus 1 is 1/2, right? U to the 1/2 plus the constant c. And then eventually, u to the 1/2 is what? Square root of u, right? So we get 2 times square root of u plus constant c. Do you see that as a circle in this direction, right? So I want you guys to remember 1 over square root of u du. What is antiderivative? Remember this, 2 times square root of u. Okay, that's antiderivative. So here, same thing. We have 2 times square root of u. This is capital F. We have to evaluate it from 1 to 4, right? So that gives us the 2 times square root of 4 minus 2 times square root of 1, right? And then eventually we should have what? Square root of 4 is 2. 2 times 2 is what? 4. Square root of 1 is 1 minus 2. Eventually answer is what? 2. Any question about this problem? Okay, in class, I cannot cover every single question for us. However, these give us the good examples for, both types, indefinite and definite integrals. So after class, I want you to read your textbook, do your homework assignments, do your review questions for the exam. Okay? All right, guys, let's call it a day. Let me see how to, you guys, we had a great class today, okay? So next time you could just, access to the class the same way as you do, or you can come to class physically as well, okay? So I'll see you on Wednesday, same time, okay? All right, so how to turn it off? This is, Stop recording. Okay, do you want to stop a class recording? Yes.